This is the first topic video in the Newton's second law unit, and the test is going to be 3 questions kind of concerning these 3 topics. According to Newton's second law, under what circumstances will an object accelerate? How are force and mass related to acceleration? And then solve problems using the formula for Newton's second law. It's nothing like the formulas we had to work in with the acceleration unit. So this is some of our vocab. If all of this looks new to you, you need to go back and watch the force unit intro videos. It's going to be a part 1 and a part 2. I'm not going to watch the video. So this is force, mass, and acceleration. It's on page 15 of your textbook, or your notebook. I don't know what that's doing there. So far we know. This is from the review. We know that force is directly related to acceleration. That means as in force increases, so does acceleration. We know that mass is indirectly related. So these were vocab words. So as mass goes up, acceleration is now going down. Okay, Newton's second law. The rate of acceleration is directly related to force and indirectly related to mass. And the answer to your question from the opening objectives, all objects will only accelerate given the presence of an unbalanced force. So here's an object, like a book, sitting on a table. Gravity is pushing down on the table. The table's pushing up with the normal force, and they're equal. They're balanced. This would be acceleration equals 0. The book's not going to go anywhere. However, as soon as you push your hand on it and apply a force this way, now forces are unbalanced, and the object will accelerate to the right. Okay, proportional example number 1. So this is a type of question you will see on your test. If the mass of an object quadruples, how will its acceleration change? You don't have to write the words, but I would do proportional example 1. This is a test example, so I like to highlight these in blue. Before, the acceleration equals 20 meters per second. And then maybe after mass times 4, what would the new acceleration be? Well, acceleration is indirectly related to mass. That means if this goes up, this goes down in a proportional way. So if mass quadruples equals 1 over times 4, so that means acceleration is now a quarter of what it used to be. So a quarter of 20 would be 5. If mass were only doubled, it would be half of what it used to be, 1/2. And acceleration would be 10 meters per second squared. Proportional example number 2. If the force on an object doubles, how does the acceleration change? This is before, tiny motorcycle, 10 meters per second. Gigantic engine, after, force times 2. Well, acceleration is directly related to force. So, if acceleration changes by a factor of times 2, then acceleration is times 2. This would be 20 meters per second squared. One of your assignments that you're going to be doing in your notebook is to write your own, with pictures, questions like these. They're just a before acceleration, solve for the after, given some kind of proportional change, doubling, tripling, quadrupling, and so on. Okay, using the formula. Force equals mass times acceleration. So that's your formula. Formulas are in green. Write this down. Force equals mass times acceleration, words. In units, but this is words. In units, force is in newtons, mass must be in kilograms, and acceleration is always meters per second squared. So this is important. This must be in kilograms part. Let's do a quick unit conversion refresher. What if you know the object is 500 kilograms? You cannot put 500 there. You must first change it to kilograms. So we've got the boxes that are on your old stuff. This is meters, liters, and grams, and this is getting smaller. Kilograms is up here. So if I'm going from grams, 1, 2, 3, left, that means I move the decimal, 1, 2, 3, 0.5. Try the next two on your own. So here's when I'm asking you to do examples now, I go right through them. You will pause the video, and when you're ready to see what the answers are, unpause. So pause the video. Here comes the answers. Move it to the left, 1, 2, 3. 0.02. You don't have to include the last 0. You can. We don't worry about significant figures in this class. Kilograms. Now we're going the opposite way. 1, 2, 3 to the right. 1, 2, 3. 2,200 grams. Alright, here's a formula for gravity. Formulas are in green. I will give you this one on the test. Force of gravity equals mass times the acceleration due to gravity. What you need to remember is 9.8. G equals 9.8. So the formula for this is Fg equals m times g, which is this. Or you may see it as weight. This is what we call weight. We'll go over that later. In this gravity example, solve for force gravity. Mass times g. 5 times 9.8 equals, this is tough, 49, I think. And then the answer is newtons, because it's a force. So 49 newtons down, which also means it's just a box sitting on a table. So that means that the force normal is also 49 newtons, only up. And they cancel each other out, and the object sits there. We'll practice this more later also. Alright, last one. Formula example. A 15-gram toy car is pushed by a child with a force of 10 newtons, and we'll just call this to the right. At what rate will the car accelerate? Do not copy the words in your notes. Write formula example and draw the picture I'm going to give you. So here's a car. We know it's 1,500 grams. And it's feeling a force. Well, we can do it this way. To the right of 30 newtons. That's your question. Acceleration equals. We've got our list what we know. We know F equals 30. Acceleration equals question mark. Mass equals 1,500 grams. We need to change this first. 1.5 kilograms. Our formula, F equals ma. 30 equals 1.5 times a. Divide by 1.5. And we have, I don't know, 12.5, I think. I don't know, let me check it out. 30 divided, 30 divided by 1.5. That's 3. Come on, coach. Get it together. 3, 0 divided by 1.5 equals 20. 20 meters per second squared. That way. Think that's it? Well, net force, really quick. Write this definition down. The sum of all forces acting on an object. For example, the net force here is 20 that way. 30, 10 in the opposite cancels out, so the answer is 20. Try this one. Here's the answer. These two cancel. 30 to the right. Or this one. Try to write it down. Here's your answer. Cancel, 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 cancel. F net equals 0. And last one. We'll get to this one later. This is a Pythagorean theorem one, right? This is just like our velocity and displacement. Okay, there's an assignment to do on the bottom of the blog. Good luck.